In this video, we'll learn about tree recursion. So first of all, I will compare what is linear recursion and tree recursion. Let us see. See, a linear recursion, a function that is a recursive function, if it is calling itself only one time, you can see that the function is calling itself only one time. Then it is a linear recursion. So already we have seen in the previous video that the functions which are calling just one time, and we have seen head recursion and tail recursion, but in this example it is having something to process before the call as well as after the call, so it is just a recursive function, right? We cannot name it as head or tail recursion. And this code is not a C or C++ code. I have just written a pseudo code here. So it's not a complete function like now integer, everything is not there. So don't try to read it as C language code. Just I am showing you structure. Then here, tree recursion. So what is tree recursion? If a function that is recursive function is calling itself more than one time. So here you can see it is calling itself first time, and here it is calling itself second time. So if a recursive function is calling itself more than one time, then it is tree recursion. So in my example, I have shown it as 2 times. So it may be more than 2 times also. So that we call it as tree recursion. So here I have one example of tree recursion which is similar to the previous examples, only the difference it is calling itself more than one time. So I will trace this one and show you how it will work and what will be the output, and also I will show you how the stack is created in this one. Let us look at the tracing of this function. The function is called by passing value 3. I have taken a piece of stack. I am not taking complete memory, entire memory, just I am showing you stack, how it is used by this recursive function, which is a tree recursion. Let us trace. First it is called by passing function with value 3. So the first call is fun of 3. For this function, an activation record is created and the value of n will be 3. So this is the first record created. Then what are the steps it has to perform? First print the value, then make 2 calls. So it will print the value, then it will make 2 calls. Let us print the value. See, it will print the value 3 and make first function call fun for n-1, that is 2. And second call it has to make, that it will be doing once this call has finished. So let us first finish first call. So for this call, and again activation record is created where the value of n will be 2. Now for this call, let us see what happens. N, that is 2, is greater than 0. Yes, 2 is greater than 0. Print and then make 2 calls. So let us do it. Print 2 and make 1 call with n-1, that is n-1. So 2 minus 1, 1. Then second call it will make after finishing this one. So far we have 2 values printed. So I'll also be writing the output here. So the output of the function so far is 3 and 2. Now let us continue with this call. This call, again an activation record is created and the value of n will be 1. Now for the value of n is 1, 1 is greater than 0. Yes, it is greater than 0. Then it will perform 3 steps. First print 1, then make 2 calls. So first it will print the value that is 1. Then it will make first call with reduced value of n. So this is 1, so it will be 0. And second call it will make afterwards. So for this call, again a fresh call is made from here. So a new activation record is created where the value of n will be 0. Now this time fun of 0, this is 0, 0 greater than 0, no. So it will not enter inside and it will not perform these steps. So the function call terminates. Now the function calls terminates. This activation record is deleted from the stack. So before deletion, if you count 1, 2, 3, 4 activation records, How many calls? 1, 2, 3, 4. 4 calls. So 4 activation records are there. So this is deleted. Now once it is deleted, it will go back to the previous call. It means this has finished. It will go back to the previous call. In previous call, for performing 3 steps, first was completed, second is also completed just now, third one has to be performed. So it will make a call here for n minus 1. Next call, n minus 1. So n minus 1, 1 minus 1 is again 0. So again it will make a call with value of n as 0. So again the activation record is created. Actually this was gone. So new activation record is again created. So I have erased this one. So let us assume again it is created here. So now again the size of the stack is 4. Next, for fun of 0, this is 0. 0 is not greater than 0. So it's not going to enter inside function ends. So this activation record is deleted and this function terminates. So now you can see that for fun of 1, all 3 steps are completed. Printing, calling itself 2 times with reduced value of n. That is 1 is printed and 0, 0 is called and they have finished. And in the output we also have 1. Now this call is completed. All 3 steps are over. So it will go back to the previous call. So go back to the previous call means this call has finished, means this activation record is deleted. So right now there are only 2 activation records in the stack. One is for value of n as 3 and value of n as 2. Now it is back on this call where n is 2. And in that, out of 3 steps, it has already performed first step, printing of 2 and call. Then the next, again it has to make a call, that is n minus 1. So now it will make a call for fun of n minus 1. So again fun of n minus 1, that is 2 minus 1, that is 1. Now again a fresh call. So new activation record is created. Now for this it is 1, so it will print 1. Now all these things that happens will be similar to this one. So it means it will print 1 and then it will call itself for, now I will not write complete name fun, I am just using f because of lack of space. F of 0, so this activation record is created again. Then this ends, so this is deleted, then goes back, again call for 0. So again an activation record is created for 0 and this ends and this is deleted. Now control goes back to this is finished, goes back to this, all 3 steps are finished, then goes back to fun of 3. In this it has to perform one more step, that is fun of, this was 2, so this is also 2. So 3 minus 1, 3 minus 1. So again 2 calls are made. So already this portion we have seen it completely. Same thing happens here also. Here also same thing happens. Now this I have taken enough space for explaining this one. Now this I have to write it in small size, but it will happen as it is what has happened here. So let me finish it quickly. So the first thing happened is value 2 is printed. 2 is printed. And here activation record is created. Then call for fun of 1. New activation record for, this was gone, sorry. So 1 is created. Then for this value 1 is printed. Value 1 is printed. Then call for fun of 0 and this ends. Activation record one more is created with value 0 and this ends. And again a call for fun of 0. Again and 0 and this also ends. This also goes back. Here fun of 1. For this 1 is printed. So output is 1. Then call for fun of 0, call for fun of 0, right? So again 2 more activation records, then that also finished, this also finished, and finally 3 also finish. So this is the output that we get. So I have simultaneously shown you how the activation record works. So You can see that maximum size of the stack was how much? 1, 2, 3, 4. Maximum was 4. 1, 2, 3, 4. And total how many activation records are created? As many calls are there. Right? I did not draw all, just I have given the idea. I did not draw each and every call here. So if I count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total 15 calls are there. So 15 times activation records are created and deleted. Now I will remove this stack and redraw this tree once again, and we will analyze more on the tree. I have redrawn the tree once again. Let us analyze the tree, so by which we can analyze the working of this recursive function. So here is a tree. Now first of all, let me label the calls in which order they are called. See, the first function call is this one, 1. Then second call. This will be done once this has finished. It has to finish. So under that, there are 3 things again. So second call, printing is done. Then third call. Then this one will be done once this has finished. So under this, printing. Then this call, fourth call. Now this is fun with value 0. This will terminate. Then it will go to this call. So this is fifth one, fifth call. Then as this has finished, it will go back and then it will make this call. So this is sixth call. Then under this, seventh and eighth. Now these are also finished. So under this, if you see, all the calls are completed. Now it will go to this one. So this is the ninth call. So that is the ninth call. Ninth activation record to be created in the stack. Now height is how much? 1, 2. So only 2 will be there in the stack. But the count, if you take this, the ninth one. So this is ninth call. Then under this, printing is done and this call is made. So this is the 10th call. And then printing is done and this is made 11th call. And this will finish now because value of n is 0. Then this call, 12th call. So this is also finished because the value is 0. So this will also complete. All 3 steps are completed under this one, 12th call. Then go back for this one, right side. 13th call, then 14th call and 15th call. So that's what already I have counted them. So total 15 calls are made in this particular function when we pass the value as a 3. So I have shown you the order in which the calls are made. This is very important for you to visualize or trace how these type of functions work, which are calling themselves more than one time. Now we will analyze the time complexity. So time complexity depends on the number of calls. Yes, in each call it is printing, except in the calls where the value is 0. So otherwise it is printing almost for every call. Then, now let us see how many calls are made if the value is 3. So for n, how many calls will be made? With that we can decide the time complexity of this one. So let us analyze this one. So if I count the number of calls level wise, then in this level just one call is made. And in this level, if I see, 2 calls are made. 2. And in this level, 1, 2, 3, 4 calls are made. 4. And this level, 1, 2, 3, 4, 5, 6, 7, 8. 8 calls are made. So it means when I have passed the value as a 3, then in the first level 1 call, next level 2 call, next level 4, then next 8. For 3 there are 4 levels. And if the value of n that I am passing here, this value n, if it is 4, then there will be 5 levels. It means the tree will be more bigger than this one. Then how many calls it may be having? So let us analyze this one. So for any value of n, how many calls it will be? So let us sum up all these. So I will take the sum of all those. 1 plus 2 plus 4 plus 8. This is total 15. Yes, we know this. Count all of them, that is 15, or you have add all these, you get 15. So this is nothing but 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3. So this is nothing but sum of the terms of, that is summation of terms of series, that is GP series. that is sum of geometric progression terms. What is all that GP series and all, we will learn some other time, but right now I'll just write on the formula. So this will be nothing but 2 power, highest term is 3, so this is 3 plus 1 minus 1. So it means if I have 2 power 0 plus 2 power 1 plus 2 power 2 goes on to, if this is n, then this will go till 2 power n. Then how much that is? This is 2 power n plus 1 minus 1. So that many calls it will make. So what is that equal to? So this is order of 2 power n. So total 2 power n calls are made. So if I substitute the value of 3 here, so 2 power 3 plus 1, 4. 2 power 4 minus 1, that is 16 minus 1 is 15. So for any value of n, the number of calls will be order of 2 power n. So that's all. We have seen what is tree recursion, and we have taken one example, and we have seen how the tracing tree is generated and how the calls are made, how the stack is used, and what is the time complexity. So for this example function, it was 2 power n. So it depends on the function what time complexity you may be getting. It's not that every tree recursion will have 2 power n. For this function, it is 2 power n. So the time is order of 2 power n. Then what is the space? What is the space complexity? So it depends on what is the maximum height of the stack, because total activation records depends on number of calls, but how much space it was occupying inside the stack. So you have observed that same space was reused inside the stack. One activation record was gone and the same place another activation record was created. So we don't require much space, just like 2 power n, but we require the space equal to the height of a tree that we got here. So 1, 2, 3, 4. If it is 3, 4 is the space. So if it is n, n plus 1 will be the space. So it is order of n. Space complexity is order of n. So maximum stack size that we need is n. That will be sufficient. So that's all about tree recursion.